Assalamualaikum and good day everyone. Today, me and my group will presenting for subject ATF 31303 Application of Mathematics and Statistics in Business. So our lecturer name is Dr. Muhammad Jafri bin Muhammad Nasir and me and my group from group 3.
Assalamualaikum and hi everyone. My name is Nur Auni Nabila and my metric number is A24833031. And I will be presenting on behalf of my group. Our group members are Nur Auni Nabila, myself, Aini Faiha binti Muhammad, Nur Mazliatul Natasha binti Khairul Azhar, Amira Aisyah Akila binti Amir Murad. Now for the introduction of our project. Statistical analysis is important in business to understand data, find trends, and help in decision making. In this project, we use real dataset with 1,338 life insurance records. It includes variables like age, gender, BMI, number of children, smoking status, region, and insurance charges. Our main objective is to see how age, BMI, and smoking status affect insurance charges.
Next, for the sampling data and collection process, we use JASP software and applied the simple random sampling method. Here are the steps we followed. Step 1. Open the dataset and run the code in JASP. Step 2. Save the sample data as a sampled data.csv. Step 3. Reopen the new file. Step 4. Run the code again. Step 5. Sampling method used was simple random sampling to make sure our data is fair and unbiased.
Assalamualaikum. My name is Nur Mazliatul Natasha binti Khairul Azhar. My matrix number is A24833326. Now, I will explain the descriptive statistics section of our analysis. In this part, we focus on three main quantitative variables, which are age, BMI, and insurance charge. These variables we chosen because they are continuous and highly relevant to life insurance pricing. Starting with age, the mean age of the individuals in our sample is approximately 39.08 years, which means most people are in their late 30s. The median age is 39, which further supports that the central value of the dataset is consistent. Interestingly, the most frequent age is 18 years old, showing that there is a large group of young adults in the sample. The range is quite wide, from 18 to 64 years, with a difference of 46 years, and the standard deviation is about 14.22. And the standard deviation is about 14.22, indicating a high variability in age among the individuals. Next, looking at insurance charge, which is our main variable of interest. The average charge is RM 13222.80. However, the median value is RM 9307.10, and the mode is slightly skewed. The range of insurance charge is extremely large, from RM 1120.65 to RM 63770.43, which gives a range of over RM 62,000. The standard deviation is also very high at RM 12350.42, which confirms that there is a lot of variation in how much people are paying for their life insurance. This could be due to personal factors such as age, BMI, and especially smoking status. In conclusion, this descriptive statistic help us get an overall picture of our dataset. They show not only the typical values but also how much variation there is, which give us clues about the possible influence of different personal and lifestyle factors on insurance premiums. That's all from me.
Hi, I'm Aisha. I'm going to present about hypothesis testing. Hypothesis testing is a way to make decision about a population using data from a sample. It involves two statements. The null hypothesis, a default or starting assumption. The second one, the alternative hypothesis, what you might believe instead. The goal is to see if the sample data provide enough evidence to reject the null hypothesis in favor of the alternative. So the purpose of hypothesis testing: first, determine evidence that supports or undermines a claim. The second one, make decision based on information in data. The third one, assess the relationship on or difference pertaining to two variables. And the last one, minimize the chance of being incorrect in coming to a conclusion. The important in the field of statistics in hypothesis testing, the first one, scientific research, to support researchers when testing their theoretical understandings in claim finish in a systematic and unbiased way. The second one, business management, to help managers take better decisions based on data and statistical analysis. The third one, medicine, help medical doctors and medical researchers when assessing the effectiveness of the new treatments and drugs. And the last one, social science, to help researchers to gain more understanding of human behaviors, aiding them in their endeavors to accurately conclude more generally about society. So, variable used for examining t-test and ANOVA. The first, the t-test age comparison by gender, and the second one in ANOVA by using age as dependent variable to measure comparisons of charges by gender and smokers. You can see using t-test, this is independent sample t-test. The comparison examine the difference in the mean age, BMI, and charges between two independent groups. The analysis find no significant difference in age. P equals to 0.272 and BMI P equals to 0.415, but a highly significant difference in charge. P uh, less than 0.001, indicating strong variation. This result is corroborated by the Brown for seed test, which also indicates unequal variance, variance in charge. As you can see, this is the graph for assumption checks. The graph shows two QQ plots, quantile and quantile plots, which are type of diagnostic graph used to check the normality assumption in regression models. This can also be seen in terms of one of the key assumptions, which is the difference between the actual value and the predicted value according to a normal distribution. So QQ plot means comparing the actual data quantity with the theoretical normal distribution quantity. If the points on the graph are almost parallel to a straight line, this indicates that the residuals are normal. Furthermore, if the points are far from the line, this indicates a violation of this normality assumption. This is due to the presence of outliers, queerness, or kurtosis. So the explanation: first, QQ plot for age, point close for the red straight line indicate that the residuals for the variable H1 coded are also close to a normal distribution. In fact, there is a deviation toward both the left and the right tails. This indicates that the residuals do not allow a completely normal distribution. It is also possible that there are outliers or data that has a certain squeakiness. So the second one, QQ plot charge. The points in the graph number 2 also appear to be almost above the red line, but there is a deviation at the far right, indicating that the right tail is heavier, positive skew. So this indicates that the residuals are not completely normal. This is due to a data charge tending to have extreme value outliers. So using analysis of variance, as you can see, for ANOVA, for age, we have smoker. ANOVA age table interpretation, smoker, the p-value is, as you can see, the p-value is 0.320 for smokers. Since p is more than 0.05, there isn't a statistically significant effect of smoking status on age. Gender, the p-value is 0.836 for gender. Since p is more than 0.05, there
There is not statistically significant effect of gender on age. For region, the p-value is 0.745 for region. Sin P is more than 0.05. There isn't statistically significant effect of region on age. So the last one, interaction, smoker, gender, smoker, region, smoker, gender, region, all interaction p-value 0.800, 0.918, 0.546, 0.998 respectively are greater than zero point 0.6. This implies there is no statistically significant interaction between the variable on age. That's all from me.
Assalamualaikum and hi, my name is Aini. I will continue this part, descriptive plots. The descriptive plots illustrate the mean age for various combinations of region, gender, and smoking status. Region Northeast, the mean age will generally be greater for non-smokers, white smokers, compared to smokers, black smokers, for both genders. The mean age will be a bit higher for males than females for both smoking status. Region Norwest, similar to the Northeast, non-smokers will be higher in mean age than smokers, and males will be slightly higher than females. For the bar plots, this bar graph show the average age by smoking status broken down by gender. Gender for female, the average age for non-smoking women is slightly higher than for smoking women. For the gender of male, the average age for non-smoking men is slightly higher than that for smoking men. This graph graphically verify there isn't a lot of difference in average age between smokers and non-smokers within each gender. So for the next slide, I will explain post hoc tests. Post hoc tests are done after ANOVA if there is a significant result. In this case, ANOVA didn't find any significant effects for age, so these tests are just for illustration. Smokers versus non-smokers. The average age difference is 1.564 years, but the p-value is 0.320, no significant. So there's a no real age difference between smokers and non-smokers. Gender, for female versus male, the average age difference is 0.325 years with a p-value of 0.836, also not significant. So age doesn't differ between females and males. Regions comparisons, all comparisons between regions have p-values of 1.000. This means there's no age difference between any regions after adjusting for multiple comparisons, Bonferroni correction. So for the last slide is conclusion. The study analyzed real insurance data in order to explore the effects of demographic and personal factors on insurance premiums. Descriptive statistics show that premiums were affected by BMI and smoking, but statistical tests including t-tests and ANOVA show no variant by smoker status, age, region, or gender. Overall, the findings highlights the useful of statistics in guiding decision making in the insurance industry. So that's all explanation by group 3. Thank you for listening and thank you for watching.